Good morning, Merry Christmas. Sorry for being late to solve this doubt. Uh, okay, Merry Christmas and advance Happy New Year to you all. So देखो क्वेश्चन में ही जाते हैं पहले. Uniform cylinder of radius r rolls over a horizontal plane into an inclined plane, forming an angle alpha 30 degree with the horizontal. Find the maximum value of velocity v naught, which still permits the cylinder to roll onto the inclined section without a jump. Without a jump, okay. So let us begin first with this, that let us look at the transformation from here to this point. Just it is started to roll over. Roll on this inclined plane. So what is the change in the height? Let us look at it. So change in the height of the center of mass. So this was the center of mass. I think this angle is alpha. Alpha. So it is actually 30 degrees. So we will put the values later on. No problem about that. Alpha. So the decrease in height. So what is the decrease in height? Decrease in height of center of mass is r times 1 minus cos alpha. Yeah, so r times 1 minus cos alpha. Now let, when it just rolls on this incline, let the velocity is v. So the angular velocity omega is equal to v by r, radius r of this ring. So at start, what was there in the beginning, यहाँ पे तो that linear velocity is v naught of the center of mass, angular velocity is omega naught, such that omega naught is v naught by r. So it was rolling without slipping, and once it enters this inclined plot, then also it is rolling without slipping. Now, so you know the kinetic energy at this stage. At this stage, what is the kinetic energy? You know, it is half mass m. Okay, mass. Ultimately, it will cancel out. No problem. V naught square plus this rotational kinetic energy, half mr square by 2 solid cylinder into omega naught square. So v naught square by r square. So at start kinetic energy, so let's write it, I for initial kinetic energy is equal to half plus 1/4, that is 3/4, right? 3/4 m v naught square. So kinetic energy in the final state, so ke final, in the same way it is 3/4 m v square, where v is the now. So this change, so therefore the increase in kinetic energy, there is increase in kinetic energy because it loses height. So 3/4 mv square equal to 3/4 mv naught square plus the loss in potential energy, that is mg r times 1 minus cos alpha. So let us keep it as equation 1. We will need that. Now next stage, it is needed that, see what is given in the problem, find the maximum value of v naught, okay, which permits the cylinder to roll on into or roll on to rather the inclined plane section without a jump. Without a jump mean here, when just after it enters the incline, then let us look at the motion of its center of mass. Now the center of mass is having velocity v, and let us look at the forces. So mg has a component, this is mg cosine alpha, and mg has one more component here, mg sine alpha. Now, and there, this is the normal reaction from ground in, okay. From ground means it's actually normal reaction from this plane, actually this inclined plane. So this normal reaction has to be put to zero. Now once we look at this motion of the center of mass, then this is the center of the circle, and the center of mass is actually moving in a circular path about this point. Say this point P is the center of the circle, and the center of mass is moving in a circular path. Now, so in circular motion there are two accelerations, radial and tangential. So we'll go for the radial acceleration because that is convenient for us. Here the normal reaction equal to 0. So the center of mass, I mean this is R, right? So the whole disk will be, if I draw the whole disk, it will be this one. Okay. Now देखो इधर, so mg cos alpha minus n होगा, but that n is equal to 0. So mg is alpha equal to m v square by r. So let us make this equation 2. Now we can mix up equation 1 and 2 and find whatever is needed for us to find, say. So put the value in equation 1. So 3/4 m v square means m gr cos alpha equal to 3/4 m v naught square minus mgr times 1 minus cos alpha. Okay, so there you get 3/4. So I think from this part, this equation, from this latest equation, you can solve for v naught. That's it. Thank you.